everyone. In this video we're going to take a look at the code in Xcode that I used to build the app for controlling the robot. I've coded this application in Swift rather than Objective-C, so let's get started.
Well, welcome everyone. Today we're going to take a look at the Xcode project. And now the Xcode project is the code for the iOS device for controlling the little robot. First, I guess I should mention Xcode's a free download. You need to run it on a Mac for doing any iOS development. However, as I say, it's a free download and you can basically just start building iOS apps on it. I think you'd need to register as a Apple developer with Apple, and that'll allow you to set up a team here in the application. But anyway, I've just gone ahead and created the app. I'll make this code available and feel free to modify it as you see fit or anything. If you're familiar with Xcode, you'll sort of understand that, or any development application really, they're all much the same. There's a tree over here where the different code modules or storyboards for the UI can be selected to be viewed. Okay, and from the storyboard we can modify the displays and link them up to the code behind. So what I might do while we're on the storyboard, this app is super simple. There's basically one view that basically will just dump any serial information that's come from over Bluetooth from the robot into this little text window here, and there's a joystick control for moving forward, backwards, left and right. So and that's pretty much it on the first view. Oh, and a button to connect. When you click on the connect button, it will actually take you to a second view, which is just used for displaying the Bluetooth devices that get found in the scan, and it'll display them in a table view just here, and basically all that's in the table view is the name of the device that's found. And if you then touch on it, that will try and connect you to the device and return you back to that main view. If the scan completes without finding anything, or even if it does find anything, you can actually hit rescan to do another scan for devices, or you can simply hit the cancel button and that will again just take you back to the main view. So as you can see, there's not a whole lot to this at all. Quite simple. The code involved in tracking the position of the joystick ball is a little interesting, and we'll sort of run through that. One thing I should mention, the Bluetooth serial code that I'm using is actually available from, or created by Alex from Hangar 42. It's distributed under a MIT license, so certainly free to use within the constraints of that MIT license. So basically, when I started looking at the low energy Bluetooth code, it's not particularly difficult, but at the end of the day, a quick Google search sort of pops this up, and at the end of the day, the code that Alex has produced looks quite nice. So just utilize that in this application. Anyway, let's take a look at the code. Let's start with the main view controller that has the ball on it, and we'll just run down through here. Need to import the Bluetooth core and UI kit, and also declare we're going to get some function calls come back from that Bluetooth serial code as delegate functions, and that this view will actually process. So we need to declare that we're going to see those function calls. Okay, so the way that this code communicates with the actual view, the user interface view, is we declare some outlets in this code. So a bar button, navigation item, the text view, joystick holder. So I've created a view there that the joystick will just sit in, the joystick background, which is an image, and the joystick ball again, which is an image. And in the storyboard, you can basically connect these outlets up to those particular screen elements. A few local variables as well. Stick active. When you do touch on the ball and start moving it, it's active. When you release it, it's inactive. So that's used to help track the movement of the ball. And also, we're going to be tracking movement of the ball, so we need to store the last touch position just so that we can work out where the movement's been. And also I've declared a max vector, which will be a little bit clearer once we start looking at the actual ball tracking code. However, that's basically just needed to sort of move between functions. And I've declared a timer that will control how often we actually send a signal over Bluetooth. So the first function that we come to in the view functions is, did the view load? So when the view has actually loaded successfully, we're going to initialize that serial module so that we can start using it. We're going to call the reload view, which is just down here, and basically it just tells that Bluetooth serial code that, hey, any responses that you have, please send them to me by setting the delegate to this view controller. Okay, basically we're just checking to see if the serial is ready, in other words, if a device is connected. And if it is, we set the background color of the navigation bar up the top to green to indicate that it's good, and turn off the connect button. Okay, and the next one, if the Bluetooth is actually powered on, we put it yellow to indicate that it's available but not connected, and we allow people to hit the connect button. And in the last case, the Bluetooth's off, it's not connected, we show it as red and don't bother allowing to connect because you don't have Bluetooth on. So that basically gets called there, and then we set up what's called an observer. So if some other code posts this notification, we're actually going to want to process this function here, which is our view controller, which is this particular view, reload view. So it allows us from elsewhere in the code to actually rerun this code here and update the state of the actual view. The next thing we're going to do is set up the timer, and basically we're setting it to repeat every 0.1 of a second, and every time that timer times out, it's going to fire this send info function, which is later on in the code. So let's just take a look at the way we're tracking the ball to start off with. First of all, we're looking at the touches began function, and basically we're just determining if the touch location is within the joystick ball. So if they touch on the ball, that's going to indicate that they're going to move it. If they touch it away from the ball, then we don't really even want to consider what's happening with that touch event. So basically when they touch on the ball for the first time, the stick active will be set true to indicate that, hey, we do have active stick movement. The maximum vector just gets reset, and we store that particular location as the last touch location. And as I said, basically if they're not on that ball, then we just set the stick is inactive and do nothing more. If someone takes their finger off the button and the stick's active, then if the stick has actually been moved elsewhere, what we really want to do is have it to return to the center. So basically we just again reset that max vector back to 0, and then we actually set an animation in 0.2 seconds to set the joystick ball center to be the same as the joystick background, so it just moves that joystick ball back into the center. So take your finger off, no matter where the ball is, it'll just return to center. Okay, now the crux of the ball movement is in this touches moved code. So first of all, we pick up the touch and we determine if the stick is active. In other words, someone's moving the ball. If it is, then we get the location in relation to the joystick holder. Now it's a view that the actual background and the joystick ball actually sit in, and that's what I'm using as the basis for all of the touch locations. So the first thing we do is we determine where it's moved to from its last location, and we store that as a vector. And after we've determined that difference, we actually just save this new location as the last touch position, ready to do this again the next time the touch is moved gets fired. Okay, so once we have the difference, we can actually determine where the new centre of the ball is, because we want to calculate all of our vectors from the centre of the holder to the centre of the actual ball. So we calculate the new centre just by looking at where the ball was indicating and the difference that we just got that, and that will give us the new centre of the ball. Okay, so the next thing we do is we determine the vector from the centre of the background to the centre of the new touch location, and that will just give us a vector. What we want to do is when the ball is moved, we don't want it to go all over the screen. We want it to operate like a normal joystick. So if someone touches on the ball and starts moving it, the ball will follow their finger. However, if they go outside of a certain circle, then we just want to constrain the ball within that circle, so it looks like a joystick control rather than just moving all over the screen. If they continue to move their finger around the around the screen outside of that, the ball will still follow their finger. However, it'll be constrained in the direction in a circular type fashion. So what we do is we calculate the max vector. We just do some trig functions here, and we're limiting the joystick to move a quarter of the background's view's height. So that just seems to constrain it nicely within the view, and it makes it sort of look like you'd want it to. Okay, so once we have the max vector, we just do a pretty quick little check here, and we just look at it and determine if the ball is within that maximum constraint. If it is, then we just move the ball to that new location. If it's outside of that vector max constraint, then we just plot it at the vector max. And that is basically all there is to moving the ball around the screen. So up the top we set a timer that's going to send Bluetooth information every 100 milliseconds, and it just keeps firing this send info function every 100 milliseconds. So what we do here is we check to make sure a device is connected. If it is, then we create a byte that we want to send to the actual device. So first things first, we just initialize that byte to 0. And then we just looking at the max vector. Whenever the joystick is moved, that max vector will be calculated. And we just check here to see where the location is. So we look at the X and the Y value of that particular vector to determine whether we've asked for it to move left or right or back or forward. And we just set a bit in that particular byte accordingly. So decimal 1 for left, decimal 2 for right, and decimal 4 for forward, decimal 8 for back. And we use a value of 30 or minus 30 here just to give it a bit of deadband type effect so that it's not so jittery. In fact, that could probably even be a little bit bigger, but it seems to operate okay there. If that byte is greater than 0, so there is a function to send, we create a string using that byte, and we send that to the device. Second last thing we need to cover off on is the actual Bluetooth delegate functions that will come back. So the first one is we receive a string over Bluetooth from the actual device. If we do, then we just add that message that we get to that text view. Okay, the next two we've got some housekeeping. So if the device actually disconnects, then we just want to display an alert to say it's disconnected, and we'll reload the view just to indicate what the status is. And again, it'll show that button being active again so that you can try and reconnect to it. Then we've got the serial did change state. If the Bluetooth goes off, then we just want to generate alert, and again we'll reload that view. Okay, last thing, the way that the views or the buttons and things like that on the views actually interact with this code is we have what we call an IB action. And this is for that connect button on the view, basically when it's pressed. If there's no devices connected, then we just move to the other display to allow you to connect to it. So let's have a look at the device view controller and have a quick run through on it. Again, we've got some outlets there, a scan button, the actual table view, and a little connect indicator, a little circular indicator that goes around saying it's actually, while it's scanning or connecting. We've got a couple of variables, one to hold the devices that get found and one to hold the actual selected device. When we load the view, we set the rescan button false because you obviously don't want to start scanning at that point. We set the Bluetooth delegate to actually send things back to this view while we're working on here. If the Bluetooth is not powered on, then we generate an alert and return because there's no point doing anything more. If we're all good, then we set the title to scanning and we start scanning the actual Bluetooth devices, and we set a timer here for 10 seconds just to be able to time out if we don't get a return in that time, and it will fire this scan timeout, which happens to pretty much be the next function here. So if it does time out, we stop scanning and we allow that rescan button to be active. We might just leave the connect timeout for the moment and just skip down to the table view. So that table view that we have on the view controller, we actually have to tell it how to display data. So we're just running with one section. The table view will ask how many rows does it need to display, and we just say, okay, well, it'll be the count of the number of devices. So if we scan 5, it'll have 5 in there, and we just tell the view to display 5. The next function we have here is it actually generates the cell that's going to be displayed in the table view. So for each of the cells that have to be displayed, it will fire this function and we have to fill in the data. So what we're doing is the cell label is going to be loaded from the devices array using the index path row that will actually tell you which cell it's going to display. So it's going to select the correct peripheral name and display that in that label. The next thing we have the did select row. So if you touch on a row to select it, this will get fired. So first of all, we just deselect the row so it doesn't stay highlighted. We stop any scanning that may be happening, and we set the selected device to be the one at that particular index path row in the array. And then we try and connect to it. And we set a timeout for connecting for 10 seconds as well. Now, we did see that function up here, connect timeout. So if it did time out when it was trying to connect, then we just basically do some tidy up stuff and just prompt that it's failed to connect. So then we're getting into more of the Bluetooth delegate functions where, okay, the first one, it did discover a device. So the first thing is we check if it exists in the actual devices. If it's the same, then we don't add it to the list again. If it's different, then we add this device to the devices array and we sort it and we reload the table view so that it will show the new device that's been found. If it fails to connect, then again we raise an alert. If it disconnects, then again raise an alert. Once the device is connected, we basically just fire that notification we were talking about that will actually return us and dismiss this view controller. So we actually reload that start view controller, the main one, and we actually dismiss this view controller. Also, if the Bluetooth gets turned off while we're doing any scanning, then we do the same thing. We reset the indication on the main view controller and basically just dismiss this one. Okay, so there's two buttons on this view, one to cancel and one to try again. If we cancel, we basically just stop the scanning and dismiss this view controller, so we automatically go back to the other one. If it times out and someone hits the try again, then basically we just go through the whole process again, exactly as we did at the starting, so even to the point where we set the timeout timer again. So that's the code behind the actual control. That's pretty much it for the code. There is a simulator that you can run on the Mac for testing code out, but it doesn't really work with the Bluetooth functions, so it's sort of not a whole lot of use. But what I might do is just shoot a little bit of video of the app itself, just to show you how it is in the finished state, and I think that's where we might leave it. Okay, so shooting this by hand, so I'll try and keep everything in frame as best as possible. Basically, this is just the startup screen. As we said, Bluetooth is enabled, so we've got the yellow background and the Connect showing up. That little text view there, obviously nothing in it, and then the joystick control. If we touch on Connect, it takes us to that other view, and I've actually got the robot going. So the actual device is showing up. So if I touch on it, it's connected now, and it's taken us back to that other main view with the top highlighted in green, indicating that it's okay. And the joystick now moves around, and you can see how it gets constraint within that circle. So look, it works quite nicely, a nice little simple app, and as I say, I'll post the code for it on the website, and good luck.